Hello, everybody. So we made it to module 8, the end of the semester. It's coming up very, very quickly. Graduation ceremonies here in Sellersburg start tonight for some people. I can't remember which one's tonight, but the IT one's tomorrow. So exciting week for some people, and then finish things up and get a bit of a break before the summer semester. Some break before the fall semester. Hopefully everybody's registered, ready to go. Please, if you're not registered already, please try to do so before you leave for the summer, the break between spring and summer, because classes do get canceled for low enrollment. So here's the end. And that way you're also when you get back to day. But we're almost finished here. Big thing I want to look at today was someone did another shader. I'm gonna do that twice. So we'll do a quick water shader. Some more these things are how the logic on them goes together. Couple more notes on the logic of how it's working. I didn't want to do that on the first one because that's going to be very overwhelming. There's a lot to it. Another one we have temperatures today. The one we use second most often with noise instead of random numbers. And just a few minutes ago, I was thinking we might have time to do something in Blender that can make a big difference with your models. We can use noise textures, right? We saw in Blender how we set up the vertices in space. We start with cube and add a bunch more vertices and faces and edges. And keep expanding that. We can also use nice looking noise textures to just automatically get a bunch of points in space and make things look really, really good. I just thought of it a few minutes ago, and I kind of want to show it, but also it's something that would be very, very overwhelming to Blender. So it might be too much when we could spend that time working on final projects and let's do homework and homework, and there's a lot of other stuff we're going to work with this semester, right? Studying for exams and other classes, I'm busy, so I should probably not do that super complicated thing, but you'll see how the noise takes. And also, if you didn't see the announcement this morning, there was a module 8 discussion board, which was just to the group, have a group share the projects, but has had a good discussion board, so is at least one person in their entire group just dropped. Seemed to have dropped the class. Trying not to stress too much about the power projects. I was looking for experience working in a group. So hopefully everybody's got some lessons about that, right? When we sent David and I were talking about this right before class started. Sitting at a computer by ourselves, doing that independent developer thing. We can let the story flow, we can make changes and stuff, but obviously that's not gonna work as a group, right? You got a group and then try to let the story and game flow as you put it together, you're never gonna get anything done. So hopefully you're picking up little lessons like that. And I'm gonna be very generous when the grades get assigned for that one, because just give me what you can. Right, so probably expect a good grade unless you don't turn anything in on it. Let me see that you have been working and trying to do something on it. And hopefully everybody's gonna walk away with some lessons about working as a group, because and learning the game development is a very large thing, so we do usually do it in groups. Okay, I think I'll talk about another common noise texture, and then we'll do the shader. And then maybe I can do a quick run of something simple for do like a block wall or something really quick. Or just go with time to work on projects. Time to work on projects is probably better, right? Would you rather have time to work on projects or see something Blender? Oh wait, actually I have a one of the Blender tutorials I made is of it, so I could just send y'all the Blender tutorial if you're interested in that one too. And then that way we have plenty of time to look at that. So we'll talk about noise texturing. The second one that we use most often. It has a little bit of variety, but we saw Perlin the other day, which is a nice way to smooth things out. We start with random numbers. Maybe I can pull up a picture of Perlin. Perlin noise. Images. Oh, this picture looks pretty nice for it. So we start with random numbers, and then we start taking samples. So we have I remember the graph the other day, we have a whole bunch of random numbers. And then we repeat the first one, so that our first sample that takes only the first, and then the last number, which is a copy, gives us a perfectly straight line. And then we'll take another sample, maybe 3 spots throughout there, so we have a little bit of up and down. And when we average that with that perfectly straight line, we're gonna get something way smoother than the plot of that original. We add some grayscale in there, we start getting smooth curves. You can see as it progresses over time on this image. Right, just a couple of samples, we just have a light spot and a dark spot, a really smooth transition between them. And we get a couple more light spots worked in, and this is what we used to create those clouds the other day. A little bit more. Eventually, it starts to look like white noise. In this picture, it looks a lot like white noise, but it's not the random static white noise like you might be used to. If you stared at that for a moment, you would notice the definitive pattern to it, and sort of repeating cycles from that smoothing process. That's Perlin noise. It was invented for the original Tron movie and won all kinds of awards, decades and decades and decades. It's really fun. And the code's not that bad. Probably show you some of the code for it. It's really fun to code those things too. I did some noise last summer. I had to get ready to teach a Java class. I've done Java in a couple of years. So I need to review the language. And I've just finished a really interesting math class up at ISU on nonlinear dynamics, also known as chaos. So I use some of the chaos things to make noise textures, but I did include a Perlin. It was for review Java, but I did include a Perlin and boring Gordy. This one we're going to get today. So for development class. So we start with a random number. And yeah. So we start by filling an array up with just a bunch of random numbers. So a lot of that's just setup stuff, get our objects ready. And then we fill an array, however big it is, with random numbers. Like some probably 512 by 512 by default or something normal picture size. And then what we do is we start looking through it. And it's a big 2-dimensional. We could have just 1-dimensional one, which makes really, really nice looking mountains background, or maybe not, I should say mountains. It makes really, really nice looking parallax backgrounds for 2D parallax stuff. So imagine like this 3D picture here, if you just cut a slice off that, that's what 1D Perlin was. So then you have a really nice, like hilly looking background or something. You can see here it's common to use for like terrain generation. Side view ones that I was to see. Maybe not like this. When we set 1 dimension, it looks like that. And with 2 dimensions, we get the full table and smooth transitions that we can use to generate terrain and stuff. But we just blew through our array. And we kind of go through several passes. Um, I did stick with some of the keywords like the original, so we call it octaves, like how many samples are we taking? And we go through and uh, they use musical terminology they reach slides. So we take samples of that, all those random numbers in the array, and a different number of samples each time, and do that. And then we start blending them together. So one minus whatever number we're on, and that's that blend thing there is like a percentage. You make of that. So as we get closer and closer to it, multiplied by the number one average. So now with a little bit of a mess, make it look better. But that's why I wasn't just gonna do it with picture, and I just wrote it down. We look at the code. But after you do that over and over and over again, and octaves is the number of times you're gonna do it. And it could be well, like that picture we used now. The sample. This first one probably like 3 octaves, so we just did 3 passes. Versus over here where we do like 40 or 50 passes and then we those numbers together, they just get more and more. We still have that smooth transition between. But you can see it's, I guess they start on line 32 and so from line 32 to 50, the other parts there are just for cleaning it up in the picture and getting the grayscale together. So what is that, 18 lines of code? It doesn't take much to write those noise generators. Kind of fun. That's the one we probably use most often. It's used for rain generation and all that stuff, but doesn't look very organic, right? Sometimes we need, or yeah, actually, when we use the word organic, um, that'll fit. Makes sense. It Berlin noise does look organic, but the next one's going to be more organic. Maybe we want some sort of structure, like connected stacked lattice structure, right? Something almost like a grid, but we don't want a perfectly straight flat grid. That's where Voronoi noise comes in. Whoop. Oh, thought I had the black marker in my hand. It shows up a little bit better on the camera. I'm going to put something in parentheses here. So another very common one, actually probably more common, but I'm not going to try to do it on the board. Voronoi is a subset of this other type of noise called musgrave, where we have n equals 1, and I'll talk about what n is in a moment. So for Voronoi noise, which is also a Musgrave noise with n equals 1, we start with a nice big grid. Bigger, and do like a 3x3 on the board. So we start with a grid, and then we pick a random point in each grid space. So maybe we'll grab this one, and then this one over here, over there, one there, one there. Something like that. We have a random point in each one, and then we go through every point in that grid and figure out which of those random points it's closest to. And that's what n equals 1 is. So like this point here is definitely closest to this one over here. Whereas a point down here is probably closest to this, or one here, it's in this cell, but it's definitely closer to this point down here. So we find the closest one, and N is, we could also do the third closest, or the eighth closest, or the 27th closest point. A computer could do that. I'm not even going to try to draw that on the board, but we find the distance to all of those random starting points and figure out which one it is. So then all the points that are closer to this one than they are to either one of those will probably look something like that. Doesn't necessarily have to be perfect. Then that gives us, you can see there it's kind of breaking up that really solid grid structure. Right in between those, right in between those, right in between those. And we just choose all of the points that are closest to a particular one. This one looks something like that. Come right in between those, over to here and back up like that. See how we still have that nice defined structure to it, but it's much more organic than that solid grid we started with. And with n equals 1, we're still pretty close to a grid. It looks a lot more organic. It looks a lot like pictures like cells and trees. You may have seen those in biology class. Right? They're very structured. They almost look like a grid, but every single one's unique. Or human skin cell. And as the n gets higher, as we go to the third closest point or the eighth closest point or whatever, instead of going just the closest one, because the computer has no trouble with the calculating and comparing all of them really, really quick, it becomes more staggered, but it kind of keeps that structure. So something like this. And then we can add a grayscale. So the distant, that one over mouse is hovering over, obviously the one's closest to the initial selection, the random point we selected is white. And as we move further away from it, it gets more and more black. But we can reverse that, right? We tell the computer what to do. This one is clearly black close to the points, and it gets white as we get further away. And see how it gives us a nice organic structure that seems very natural. I was thinking of taking something like this and put that on a cube in Blender, and then tell it to use that to come up with a bunch of vertices and edges and new faces, and then we can adjust them a little, make them really quickly instead of going through and making like every single, or I guess this would be more like a rock where somebody collected a bunch of creek rocks and stacked up a wall. It looks a lot better instead of going through and making every single one themselves. So between those two, it covers a lot of the textures we want to get because we can vary that tremendously. Right? Different sizes on the cell structure, but it's well defined. So that's the well-defined structure, and then Berlin is the smooth transition noise. That's why those two are probably our most common that we come across. This one's even shorter. So the constructor that sets it all up, several constructors. So we go through this grid, whatever size it is, 64 by 64, it's a good size. And then we pick a random point in every single cell, random somewhere between the next end, between whatever letter J we're and then the size of that cell, the X and the Y, that gives us a random point in there. And once we have all those random points, we can just compare distance somewhere. Oh, there it is. Then we just compare the distance between them and keep track of which one of our points, which one of our selected points, every spot in that entire grid is closest to. And then give it some grayscale. So not a super complicated thing to put together, but it makes things look a lot better very, very quickly. Okay, I can just pull out an normal example. Let's see if I have something on the drive. Let's have something on drive. Nope, I'm gonna move down. Oh, wait. Right as I close it, I guess I'll fold it. Oh yeah, but this has it. So let me download this one. And instead of going over that thing, which, oops, I can either share a link to a video if anybody wants it, or make a short video for you. That way it doesn't eat up all our class time. I try to work in groups, but this is the one I'm thinking of. It's a nice little modeling trick to make things look a lot better very quickly. It opens. It's going slow. Was traffic bad again today?
Yeah.
I saw your truck out there, or your SUV. I was like, oh, I guess it didn't get caught in traffic today.
No, I just pulled in a minute ago before I came in.
Okay. Yeah, so this.
Apparently they're closing down the one bridge. So, yay.
Oh,
Sherman,
Yeah.
it's just the west of it.
they keep closing it. There's no way to go back and make up to 30 years.
Do what?
There's no way to go back and make up 30 years without doing maintenance. You're gonna have to devote a bridge. But so this the chimney here, that uses a Voronoi texture, a Voronoi noise. So I just made a cube thing and then went over here to modifiers, which I think already been applied and stuff. But added that sort of that texture like we were just one of those noise textures like we were just talking about, and used the grayscale to have it come in and out. This is an early step. This is when it was eventually finished. Around that basic cube and get those structures. A similar thing on the other ones. This one was our early step. I was trying things.
So with something like Blender, it's not just, you can make it not just a image on the surface, you can make it raise and lower the.
Yeah, so it's not just, because what we're getting ready to do with the shaders is just gonna be an image on the surface. So there's another way to do it. Here it's actual, if I go into the edit mode.
Geometry nodes? Well, you can see the geometry just looking at it in silhouette here.
Geometry nodes are different. Geometry nodes are procedural. So we could make that as we went.
Count noise as procedural.
So noise is a fixed thing. We just do it one time and then we have that noise to work with. So procedural.
Unless you have some weird code in your code that makes a procedural noise whenever it starts up or something.
Yeah, you could do it with geometry nodes. Procedural nodes would be more for something like if you had a driving game, you could just keep making cities. If you're driving through a city, you could just keep making buildings and procedurally generate them at random as depending on where the character was. Or dungeons, those are very common. And
Yeah.
just keep generating what you need. We saw a quick noise, introduced noise the other day with the sky texture. So that's another common one, it's just procedurally generate clouds, we just keep coming up with. Use low noise textures to just keep coming up with new clouds.
The game that I played called Warframe does basically that with every single one of their levels. Their planets have tile sets of this planet has these things. And then when you load into a mission, no matter what that mission is, you have no idea what it's going to look like because you know the architecture, you know like what that planet is known for, but nothing. Even if you load into the same mission twice, the layout will be different.
Yeah, so this was an early step on this thing, so you can see there's a lot of bases of vertices there. Obviously, that needs cleaned up and simplified before trying to run it in the game engine, unless you just have a massive GPU with a really good cooling system. But it just, yeah, you can just generate those textures. I can make a little video if anybody wants to see that, because it makes your models look way better very quickly.
That'd be nice.
So make a video for it.
Yeah.
I can do that, yeah, and yeah, like, that was probably 5 minutes that was probably like 5 minutes to get that far. It's just a couple boxes and then use the noise to do that. But for us today, let me close out these.
Today, play with some parameters so you get what you like to look at.
Yeah, it does.
I assume you could do like adjust the noise and stuff till it looks like, yeah, I like the look of this.
Yes, lots and lots of parameters, so it's kind of where the buttons are and what boxes and numbers to play around with until you find it. And it's definitely something to undo and redo a lot of times, because you don't have control like when you're manually placing all the vertices. But let's look at the shader, which is a slightly different approach, because that was actually in the model, it had that shape.
I'm gonna go ahead and apologize to my laptop. It's gonna happen.
Yeah, gonna do a water shader. If you don't have a GPU on the computer in front of you, it might not like it. So you're logged into the school computer. When I tried it, I was able to do water or clouds. It didn't crash, and I tried to do both. But let's go over the steps and kind of talk about some stuff, because there's another approach than that actual shape. We can just give the impression of it. We did the other day. But an important word that we'll need is what's called the normal. The normal direction. You may have noticed normal shows up in a lot of places, and seems like it's all over the place in linear algebra sort of math, and you get up to like 600 level math, and it's like, oh wait, that's why those are all the same thing. But it's so it seems like it shows up in lots of different things. They're actually the same, but what the normal direction is the direction straight out from a plane. So like the board here is a plane, so the direction pointing straight out from that. Versus the little tray here, is that showing on the thing I'm pointing at showing on the camera? Let's get it zoom in. Quite a bit. I don't know how much it's showing up on the tray here, but I assume everybody's seen a marking tray on a board before, right? This isn't a flat surface. We have these little divots that hold the markers in place. So if we broke that up into smaller and smaller sections, every little section has a different direction that is straight out from it. And from across the room, or it's a lousy angle here, but from across the room, you can tell that that has a good shape. The shape of it, or in the video, where you're looking at it on a flat screen, you can tell the shapes there because of how the light bounces off all of those spots differently, right? Light comes from the source of fluorescent lights in the room here, hits that, and then bounces straight back off. So as it bounces off, that bouncing back is actually a different direction for every spot on there. That's normal direction. That's how we made the clouds the other day. Remember, we created that. We used Berlin noise to make it normal, which means all that smooth curvature in that Berlin noise was really just changing the direction that light was not for that. It was still on a flat surface, or that one was on skylines. The one we're getting ready to do, we're gonna do water, so it's gonna be like a flat surface still. A great new project. Um, I don't know, Riddle seems like a good name. We can probably create it quick. Actually, this works. Spell it correctly. And though in a landscape that looks like it fits with the river. So what's a lot easier on the processor, instead of giving it all those different shapes, like what I did in that model earlier. Which part of that was trying to figure out if I could get shaders to do that. So it's like, can I make it look like this with the still a perfectly flat shape? Because I don't need to go sit things on the little ledge. Maybe I set our keys on one of those ledges between the rocks. But in a game, we're not going to do that. So if we could just make it look like that, it would be enough on a flat surface, like the thing we've seen before, add mesh, and a landscape mesh. And when we expand our parameters down to the lower left, we can go to the presets, and there's probably a river down here somewhere. I'm just going to kind of go with the default one. And here we have a flat plane representing our water. We still have all those points to make the nice looking land, but water is a flat plane, so it's just the 4 points at the corner. A lot less data to transfer there. So shaders work out really nice for those. So what I'm gonna do is I'm gonna delete this plane, but I'm probably gonna come back and put another one in it later. We'll see why. Let's go with the delete the plane part and keep the river bank part, I guess. Maybe stretch this out a little smaller, maybe like 75 each direction this time. That's big enough a character to walk around it, but yeah, we're getting ready to do something that you probably need a GPU to really get. Hopefully we won't bog computers down with something this size. And we can throw in a material to give it a color, some nice green color that looks good for beside a
how much did you scale it up for?
I went 75 in each direction. Some nice dark green like we would see growing beside a river. Now very specular, and that's good enough for now, so I'm just gonna save that over in that game project. So we just created documents and take it over in Kali River. I'll just save this in Kali River. I might as well rename it here instead of calling it landscape here. We can import the name and everything, so that's why we can name the parks here. Or this would be Rural Bank, wouldn't it? Rural underscore bank. We don't actually have any water in there yet. Now we can go to Godot and do the imports like we've seen repeatedly, which is hopefully going to make the last homework assignment a little bit easier. That'd probably be, yeah, give me what you can on the group projects, and that last homework assignment, the thing we keep seeing over and over again in class, it's almost like the default state of what we get out of Godot and Blender together these days. Just some sort of 3D world, you just have to put a story on it. That's probably a better one to spend your time on this week. Let's see, I've created a new root node. Things we've all seen before, and drag that Blender model in. We have something to start with. I can already tell the shading is gonna be kind of strange there. I'm gonna do editable children, but we've seen characters walking around, so I don't know if we really need the, we know how to turn that into something a character can walk around now and put all the static body and stuff. Maybe that'll help prevent, I'll be having to use our example. And we know all the light though. I definitely want to control light if I'm gonna make the shader. If you're adding shaders, probably not a good idea to just go with the generic light that kind of spreads out everywhere around the world. Search for a light node and a directional light is our own sum, so then we can choose an angle for that to go at. Go down, this way. Okay, so we can tell from the land there that we're getting nice shadows and stuff, and those shadows come because of that normal direction. Everything on that flat surface or on that surface we brought over from Blender, the normal direction or what is considered straight out from each little face goes into different directions, so we can tell about the shading and all of that. But more importantly, is it gives us light at different angles so we can do stuff. Now I'm gonna add a plane to surface the water. So I got the group node and the mesh instance, the 3D mesh instance. Could have done this on the plane and bring that back in a few minutes and show you just something now.
Yeah.
Is water, the plane making water is definitely different than the plane making up our land, right? We don't want our character to walk on water unless it's like an icy landscape. Or in most situations, maybe do that, but water is going to behave differently. So I'm going to have a new mesh instance. Come over here and add a plane to it. New plane mesh. And I believe if I take 75 by 75 here, it should fit on that. So I went to 75 by 75, but it looks like it's only covering about half of our area that we scaled up by 70.
It's 2 meters.
Yeah, so we need we scaled a 1 by 1 up 75 times. But here in Godot, our default is 2 by 2. Oh, we just actually went to 75 meters. So instead of saying Blender scaled out in every direction, and here it gave us the exact size. So I'm thinking 150 should be a perfect fit between the water and the land, yeah. Then we just move it up or down on the y-axis to find the spot where we want the water surface to be. Looks good, and it's a nice flat surface like water. But if we go and start adding colors, let's do it with a shader because we know we're getting ready to make a shader. I'm going to click on this mesh and under surface material overrides, click in the empty spot, and we can either make a new standard material. It's all nice where you choose all the options, or we can make a new shader material where it actually writes code for it. And that out. What is our shader? A new shader. It's stuff we saw last week. We keep expanding menus over and over again, and they get pretty deep in there. I'll call this water. A water shader. Notice the mode is spatial. We make sky shaders, fog shaders, particles.
Where did you?
Okay, let me go back because yes, feel free to ask what way ask at any time. Probably shouldn't have waited until last week to say that. So let me last thing. So after the mesh was after we got the size on the mesh, I clicked on it to collapse that menu. And then right below it is surface material override. If that says empty, click on it and choose a new shader material. Which should be the bottom one on the list. And then when you expand that, we'll see a preview box and it says shader is empty. So we're making a new shader here, and this is where we're actually creating our text file. So I'll call this-
It's new shader material 3D, right?
Yes. And then set the mode to spatial. I think. Yeah. That's what I did when getting prepared. And obviously there's more than one way to do this because you also make some pretty cool water by just a really, really, really dense fog shader. Which are really awesome water, but that one will grind your GPU to a halt. We have some really good liquid cooling on that, but it looks just amazing.
Shader for the fog.
So to make a fog shader so dense that it looks like water, and then basically every water droplet's flowing and splashing, and especially
Your computer screen is like a band sheet, just
yes, it's one for fire.
about ready to go into meltdown, throwing all the eggs.
Yeah.
To sum up shaders, it is just fake it till you make it.
Mm-hmm. Yeah, basically, yeah, we just want to look at some basic things. So a much smaller one is let's just use a spatial, which is that flat surface we have, and adjust all the normals. This is just all the normals so that it looks like, instead of actually having ripples in the water, we just let the bake shit. Kind of what the ball shader would do. That's almost like procedural water. It looks like light is reflecting in lots of different directions, but it's still a perfectly flat surface. So once we have that, down at the bottom is the shader editor. So we expand that and double click on this, how we did it in this. I think this is the screen I can't zoom in on. Yeah, this is the one that it won't let me zoom in on. Oh, it did. Awesome. They updated it in 4.2. 4.0 and 4.1, I couldn't zoom in on that font. I can zoom on the other editor. Notice we have a couple things, vertex and fragment. Only vertex the material is visible on, so that, well, we're doing it on a plane, so we have 4 vertexes in the corner. That's why we wanted to do it this way, so that it was a lot smaller, so get rid of those. This is what you'll do a lot in Unreal, for those wanting to make stuff in Unreal. It's really the shaders there, and the keyword that you want to Google here, for Godot, Unity, Unreal, GDevelop, JMonkey, whatever they're calling that one they don't Quake engine. It was originally moved to Quake engine, but they keep changing the name.
Intech something. Is it Intech?
Yeah, it's most probably the one that uses Java. They change the name every few years, but it's still the same thing. But almost all of them use this language called OpenGL. So this is what you want to search for. Search for keywords and syntax and things like that.
Intech something.
Yeah, whatever. Yeah, they keep changing the name on that one. They've stopped coming up with good names, like alphanumeric things. No. We've also a light one called for every pixel. Every pixel the light is affecting. Notice how it's commented out by default.
Yes,
All of your engines have access to it because it's part of OpenGL. But in Unreal 5, that's uncommented by default, and that's pretty much the only one that's uncommented by default, and probably the only place you should use it on a computer with a really good thing, because
that's another thing.
if y'all know.
That's another thing that will detonate your computer.
Yes. So yeah, so that function, Unreal 5 being able to run that function out of the box is what really big it out. It's been around for years. The theory of it's easy. The implementations.
I'm going to make it so it doesn't blow up your computer.
Yeah, that's That's where we get those, and we're doing, instead of just generalization of like normals, like we're getting ready to do here, it's control over every pixel on the screen. Probably zoom in so we can hopefully get a good angle at it. All right.
What does void mean?
Void means the function does not return anything. So it's a C family of language, so we have to say what everything's strictly typed. We always have to say what type of data we have. Like we've been doing in Godot syntax. So whenever we have a function, if it adds a bunch of numbers together and returns an integer, we have to say it's going to return an integer because all of the spots in RAM have to be pre-reserved for the exact size we need. We can't be making a 64-bit integer and just ask the RAM chip to give us, 70 bits is fine. We have to say we need 64 bits and precise. So here it's saying we don't need any bits in RAM afterwards. It's the fancier way of saying that. Like, don't bother reserving any RAM because when this function's done, it'll be done. All right, so we'll go into fragment here. Actually, we'll start up at the top. Let's start with a color picker like we saw the other day. Our keyword uniform, which is global scope. It also makes it show up in our inspector and all of our engines when we type the word uniform in the OpenGL editor. It shows up in our inspector panel. What's this going to be? Watercolor. It's a good name for it. Watercolor, and if we make it a source underscore color, then end of instruction. Technically, semicolon means next instruction. And y'all have probably seen this. I'll write this out. X equals X plus 1. You've probably seen before that line does work. And that tells us that the computer reads our instructions right to left, not left to right. So technically, semicolon means end of instruction, but because where we put it in the text file, now that I've mentioned the technicality, I'm going to say end of instruction every time I type it. Which can be really, really helpful if you're not used to using language, typing a language that has that. Every time you get to the end of the line, actually say or think end of instruction, the two get used to typing.
Beginning of instruction. You mean right to left, maybe beginning?
There's a lot of extra stuff in there. So it's not the beginning yet. The beginning is the last step of what the semicolon does. So we have to set up the machine to get ready for another instruction, preserve things in RAM to carry it out, keep track of where instruction counter is on the CPU. We have to pause, keep track of everything on the machine and how much RAM we have to work with. Maybe a lot of times I'll empty out the registers because there's not in computer's a bunch of switches. We don't load stuff in register A, load stuff in register B, and then do a third step to have it show up in the accumulator. When we load stuff in register A, if register B is empty, we load something in register A, it immediately shows up in the accumulator. So we flipped all those switches on. Then when we reload stuff in register B, then we would add it together and it would appear in the accumulator. So if there's already something in a register and we go to do the next instruction, bad things could happen if we don't empty it first. So the semicolon is like, okay, empty out the registers, zero out the all accumulators, turn off all flags. Some are off flags, some are true by default, some are false by default, but we need to go back to the default state. And then at the very end, the last part of it is begin instruction. So you're on track there, Brady, but there is a lot built into a semicolon. A semicolon is that tedious instruction that we don't want to type every time. Like 10, 15 lines that we don't type every single time just to get back to our instruction. I'm looking at let's say what that is. So color is a vector 3. Sorry, I skipped over that. A uniform global vector 3 sort of data called watercolor, and The colon is for the means for the, I'll say for the inspector. So put in the inspector a source color picker. So now we go into the water thing and expand our shader. We got shader parameters. And we can choose some bluish color. Nice little blue color for the water. That looks good. And then we get down here and our keyword for that is, well, the other day in Sky it was colored. When we made materials, we saw albedo is the more technical version of uh, all of the properties go together to make color. Albedo would be the tinting and the hue that we put in there. I have no idea why I just hit the paste key. Take that out of there. So albedo equals that color we created. End of instruction. And then we wait for the compiler to do its thing. And when we save it, we now see we have some blue water. Because I don't need to roll anything to it, because you can't really see it, but got a nice little color of blue, that's it. So as you can see, that almost might be easier sometimes when you need a material. Just do a simple shader, but we can do more than that. Let's make it a little bit metallic. We're gonna have the metallic and roughness in, right? We saw the yeah, we saw the BMSR material or BSMR, BRMS. Those four letters, the order doesn't necessarily matter because it depends on how we write the code. But the base coloring, the metallic, the specular, and the roughness. Let's add metallic and roughness. Uniform floating point number, we'll call it metallic. Yeah, I'm gonna try something. So let's give it a 0.1 on metallic. Let's type the number in. And then for the next one, uniform, another floating point number, called roughness. And this time I want to put something different with the inspector. So notice over in the inspector, oops, put a semicolon there so the compiler doesn't stop panicking. Notice metallic over there, we've got just a number to type, a box to type into. A really useful one in Godot, and this one is called something different than every single one. You do hint range. Let's say the hint range on this floating point number is 0.0 to 1.0. That gives us some sort of range, and we'll start it up, and then we'll assign it a default of like 0.2. End of instruction. That's where we get the sliders. So we have that default slide up and down, and that thing we see over and over again. As soon as we move it, we can reset it back to a default value. So that's probably the way you want to type in, but I also, just for the sake of examples in class, I wanted to show that we can just put a box there if you prefer typing the numbers, but that hint range one is pretty useful.
Well, you can slide them or you can type either way.
Yeah, so now we need, well, the other day, we used one noise texture to just kind of, really what we did was the normal. We changed the normal in the skybox. It's not a flat surface that our player could walk on or anything. It's like that flat background. But here, ripples in the water are a little bit different, right? Because ripples in water are going to be different sizes, moving in different directions, all sorts of things. And as ripples start bumping into each other, ripples and waves aren't the same thing. Right? If two waves collide into each other, we get a bigger wave. Ripples are disturbances on the surface of the water. There's not necessarily, they don't have their own energy per se. So whenever the ripples collide with each other, very different things happen. That's getting into the physics and stuff, but some of our ripples are going to be very large, moving one direction. We might have some small ones moving another direction. In real life, it would probably be more than that, but for the sake of this, that's how we're gonna do. We're gonna make some, like, think of like big ripples, like you just threw in like a rock, standing by a lake throwing rocks in. Throw one rock the size of your hand, and then another one that's like driveway size peat gravel or something, or flower bed size peat gravel. They're gonna create different ripples, and then when those ripples come together, the interaction between them is gonna do different things. So two will be a good start for this. So let's make two noise textures like we had the other day. Let's say uniform, sampler 2D, and um, one and normal two. I wanted to give it some wave names, but I couldn't think of any very quick. I'm gonna think of enough, because when we start making it move, we can probably come up with things like wave and ebb and flow and different words that could be used, but we need a couple of normal maps. Oh, it never did come down here, sorry. I'm getting excited and jumping ahead. Yeah, we'll probably want to, we should finish this about 2:15, and then that'll give us lots and lots and lots of time to work on projects and stuff to finish up, right? I jumped ahead, when we created our metallic and roughness numbers, we never assigned them to anything. Our keywords, you could probably guess, are metallic. And we'll make that the lowercase metallic. So you can see it is case sensitive, that's why I called it that, but it probably would have been better to call it something, give it a different name. Same thing with roughness. The one built into the language is all caps roughness, and we'll assign with that variable we created. So then we can actually see, so you see the metallic we get a lot more reflection. That already looks a lot more like looking at water, right? If you water on a bright day, we're gonna see a big sunny spot. 0.7, something blinding, but notice how it just completely fades out when it's not that bright spot. Oh, it's 7, I'm at 0.7. I wasn't gonna go that high and see, right? Big numbers, we can see we lose everything but that spot. 0.05 as we get smaller. Oops. 0.05, try hitting the right key. Add some more zeros in there. So it's not getting much difference as we get smaller. And hopefully at this point you're thinking, what do negative numbers do?
I just found that out. Because I was already ahead of you.
It reverses our color. A couple people noticed this after class the other day. I think the Zoom call had ended by then. But we have red, green, and blue, right? I can take on here. And yellow is an even mix of red and green. We started with all blue. And then when this is about 0.1, we get white. So that means we took the blue and added green and red to it to get back to the white color. So when we go negative, we see that stuff we're adding. So here at first, that looks kind of yellowish to me. So we're like adding red and green, and even makes red and green makes yellow. And then there's enough of that, so just to get really bright, then we're adding more and more and more red till it gets white.
These are very interesting things because I could easily see that being used as a way to indicate something in a game like, oh no, you triggered the thing to happen. Now everything's going, shaders goes.
Yes, and like everything else, once you put that parameter in your inspector and Unreal and Unity and all of our game engines, once that parameter is in your inspector, you can access it from your script.
Yeah.
So it now becomes something we can dynamically control. So that's why we're just doing a small, right? This is a deep rabbit hole to get lost in. So just adding that metallic and roughness, it starts to look like the sun's reflecting brightly off there. Already looks a lot more, we're not even We haven't even added our normal samples.
What was roughness again? I was getting confused.
Roughness is like the chair you're sitting in versus the table. Right, one of them's a lot rougher than the other, right? The fabric or this whiteboard, that's very low roughness, whereas the carpet's gonna have a high roughness. It just like, same thing it means in the real world. But in terms of a normal map, so I guess we're making normal shaders, so you could think of it. Think of them as artificial subdivisions on our surface. Instead of
It being smooth.
it was, yeah. Then it's obviously one solid thing. But let me turn it off. If I add a couple of lines, watch what happens to the, see how all that went away? Still get some reflect. So with the metallic, or until we're open this all, we don't get any reflection because the only normal direction is straight out. So it's like fake subdivisions on it. And as we increase it, see how it's like spreading out. Actually, that probably looks better like a reflection. Spread it out, and then we have lots and lots of little subdivision reflections. So a big number in there. So like 7, when we lose notice it went past 1. Go to -5, went back to 0. So it wouldn't let us.
Cause that range.
Oh yeah, the range is in there. Some days you might see just a little bitty thing like this, so just that the focal point, the exact reflection of the sun. It gives us enough surfaces distributions to fake surface distributions to do that.
I'll see a 0, I can still see a fake. Of the sun.
If I turn this up, notice the metallic changes in lots of different ways. Play around with the numbers, see what you find. Roughness gives us more surfaces to work. Okay, now we need to load in these samples like we saw. So we'll go to where it shows up in the inspector. On the bottom, we choose a new noise texture. We'll click on that, we get some parameters about it. Really on this one, we just come all the way down to the bottom and create a new fast noise for the noise. And follow along and keep up on that. Get a new fast noise, and when we expand that, then we can choose one of our textures. Simplex or cellular. Or smooth simplex. Or lens stuff. Cubic numbers. Or value-based noise. That kind of looks like a ripple shape, right?
Yeah.
I'll go with that one. So go with cellular, but we can change it and stuff. And we have 2 noises this time, so we need to do the same thing for normal too. Our second normal map will have a new noise texture TD. Expand that, and under the noise section, create a new fast noise. And try burning on that. I'll try mixing those 2 noises together. That might make some nice looking reflections. But that idea, it's something to play around with. We have these different textures we can use. Now that we have those, we can create a texture from them. I'll break it up in pieces. So I'll use words like ebb and flow. That sounds like good words to go with. Seems like it fits with water with ripples. So I would create one called ebb, and that's going to be a new texture. And what we'll use is our normal map, normal 1 map, and then UV in capital letters. Seems like it's not wanting to show up on the predictive text, so just type that in manually. UV is the XY coordinates. X and Y are already used. That's what we're using, X and Y in our main game. So the next two best letters to use seem like U and V. So for the subset of things that go in our game, the U is the internal X coordinate and the V is the internal X coordinate.
Where's the
It just got skipped, I guess.
W?
Somewhere along the way, somebody decided that should be the one. Oh, what? Oh. And that's gonna be a vector 3, it's a color. Vector 3 sorted data called SDEV is created from that normal texture. We'll do that on both of them. Another vector 3, I'll call this one flow. And we'll take create a texture from that normal 2 map using the UV coordinates, which is surely the XY coordinates of the image generated. And we'll grab the RGB values from it. So what that does is it gives us a height. So we had all that white, that grayscale in the image, right? We can see it over here in the corner. We have all this grayscale. And we can split that up into a red part, a green part, and a blue part. And then we can have the computer manipulate it slightly to say the reds are closer to us and the blues are further away with the greens in the middle. And then by splitting up that grayscale from ranging from white to black, we have a close, mid, and far range on that. So not like distance, not close, mid, and range like across our world, like close and far like the keys on a keyboard. It just breaks up the surface a little. But we can define it. We can make it bigger, but you wouldn't want to, you want to limit it before what the computer is technically capable of, because then it's going to start to lose its realism. Like you wouldn't want to try to make grass that way. Right? That's a bit too tall. Ripples on water would be good. So we have those. Then we can use those to create another vector 3, which I'll actually call our color. Is that what I want to do? I don't want color. We'll make it normal. I'll call it normal water. So we'll make a normal map for the water that is a mix of those two things. A mix of that ebb, flow, and then we have that percentage we saw in the clouds, right? If it's closer to 1, 1.0 is entirely the second value we're mixing, and 0.0 is entirely the first value we're mixing. So 0.7 maybe would be a good start. So it's 70% the second one, 30% the first one. Get that sort of mix. And then our keyword down here in all caps is we'll create a normal map and give it that normal water map we just created. Started to distribute it up a little. That makes an interesting looking shading, but that's not quite what I was looking for.
That looks less, yeah, it looks like actual waves on it, less like ripples.
Yeah, so that looks like big waves and they're not doing anything. You'll definitely want to play around with this for just a couple seconds for finishing. We need some directions for those ripples to move in, right? They're separate from each other. Not quite looking right yet. So let's create a couple waves. We'll come up to the top. I'll create a uniform vector 2. Just, we could just create a vector two and use that. But it's nice to have it in the inspector. It makes it easier to try different values and stuff. And, I don't know, I'll call it wave one, wave two. Or, are there other ones I can use? I'll call it ripple and wave. That'll work. Wave one, we'll call ripple. I'm just looking for water related words here. And that's gonna be assigned to vector two. And this one I'll do a lot of X and just a little bit of Y. And then the second one, vector two, I'll call it wave. And in this one, I'll do just a little bit of X and a lot of Y. That's probably too much Y from what I was thinking of, but that might probably work. So now, we can move. When I was getting ready, I did another one of these to pick a small number for time. Actually, yeah, I wanted to go ahead and do that. Because then it'll be useful. Let's add another control to our thing. It's the same thing we saw the other day. We don't actually have delta, so we just have to make our own. But it's nice to have that as a slider. Then when we see things moving, we can just slide that, move the slider. So floating point number called timing. And that's, oops, first off, we want that to be a hint range. And how small do we want our timing to go? I'll go from 0.0 and I don't know, 0.3 is kind of the maximum. And then we put a third value in, that's the step value. Like, we don't need to go through every single increment between 0.0 and 0.3, all the numbers computers know. We can restrict it to a step size. And we'll give it a default 0.015. Should be a nice small time number. Let's see, what can you call this? Let's call this current. Oh, whoops. Well, this is going to be what type of this vector two? Vector two we'll call current, and same thing we did when we moved our clouds. We'll take the built-in time, multiply that by our different waves, ripple and wave. Maybe this current is the wave, and then we'll multiply that by that timing to make it a nice small number, because we want to do it every frame of the game. Another vector two goes with the current in the river. There's a current and flow. And the flow of the river. I'm just trying to come up with watery type words. Because I'm expecting you all to just play around with some of these and change. So as always, variable names are completely arbitrary. Sometimes, oh, did not mean to minimize that. The flow is the ripple, and then we'll multiply that by timing, which is the same thing as our delta value over in the game. Oh, I used flow twice, didn't I?
Yes.
That's not gonna work. Current flowing tide. Probably not the best word, but yeah, arbitrary variable names. They don't necessarily have to mean anything with them. And now we can do kind of like we did with the clouds moving. We have the UV, the XY coordinates of where that normal map's laid out. So let's just add to that one of the times. And then same thing on the other one. Our other texture will add. Oh, we can already see it, see when the current. So we can already, we're starting to see some movement already. And when we add more movement in, hopefully this is gonna look good. Plus 5. So now things are normal, that moves in 2 different directions. And that one might be a bit excessive. So tide is using ripple, which is going 2.30.2. What if I make this like 1? Whoops.
I've got some blockiness to it.
Side.
Yeah, you can see the lines there.
Oh, okay, that's that thing we saw the other day. One of them, if we extend the noise texture, let's make that seamless. Uncheck generate, turn on that. And this one down here, seamless blend, might need that if you get too much of it. Extreme differences in the colors, so we can play around with things and make that a little bit different. Trying this one. It's too much. It's going too much side by side. Let me go back over there.
Yeah, the direction for me looks like kind of diagonal to water flow. How do you, is there a way to?
Yes, you'll just change what direction the vector is going in.
Okay.
So that's what those are pointing at. So that's pointing the way it'll go. So if I change this to say an 8, over here we should get a drastically different flow. Kind of getting stuck there in the middle, blending back and forth. It almost looks like it's dyed though. That one's pretty dark. Let me come into the noise, all the way into fast noise, and turn up the texture. Okay, so I turned up the frequency. See how it looks a little bit more broken up now? Fractal might help too. Change fractal to ping pong. This is how we're breaking it up. That looks a little bit better. So that dark spot must be coming from this other one. Let's extend that. Turn off generate and on seamless. Extend the fast noise. Smaller. Yeah, that's what's giving us the darker color. It's a little bigger. Oh. Well, let's just move it. Let me go down to fractal again and change it to either ping pong or rich. Ping pong. You can play around with different settings, find the ones that work. There we go. Now if I turn it down, just because of the way the light's reflecting, it's a bit more of a flow. So yeah, it's no longer moving in this direction because I'm pretty sure I retyped something in here. If I can find the vector. Yeah, so it's moving at 802. And you just have to find the vector that basically points down your river so that it looks like it's flowing in the correct direction. And we have this perfectly flat surface, but again, there's always trade-offs. It's dependent on how the light is reflecting. So it's different as we see it from different angles. One other thing I want to throw in here. probably recognize the term. Alpha, our standard value that we call alpha, measure of opaqueness. 1.0 is fully opaque, 0.0 is fully transparent. Water's maybe 0.8. Pulling that 0.4, some like crystal clear mountain water. That's where it starts to look good, I think, because we have like very clear water and we don't get those other things, so we get right up on it and we see it flashing. One more thing I wanted to do, and that was probably going to be it for today. That I know we went a little bit longer to break. Our character might want to go through there, so something I often do, which I can just describe here. Remember how we deleted that plane? If I add a plane back in there, I mesh plane, it something I like to do is that plane that came with the landscape, I'll put it in there like lower than where the water is. Maybe give it a fully transparent color. And then that gets a surface the player can walk on. It makes swimming a lot easier. You keep the same collision box so that your collision box is moving along the bottom, and then just tilt your player's graphics inside that collision box to the swimming animation at the top of the collision box to make swimming a lot easier. Does that logic make sense?
Basically, they're walking across the
Yeah.
plane of swimming.
Yeah, so a fake bottom to the river you can't see. I'll let y'all play around with that. The logic's not super complicated on it, but yeah, once that water gets clear and then subtle effect and much nicer looking water. So 2 passes on shaders to hopefully you see some consistency there. All of these were words we saw when we looked at the regular material, right? The simple material in Blender. So you can also find a lot of those keywords that you need for the script by just creating a regular material and looking at what the keywords are for it, seeing what type of values go into it. Something to start playing around with, a couple different tools. Does anybody have any questions about those? If you do that in your open world game, hopefully have a nice looking water on there. And pretty small, so that one's not going to bog your computer down as much as others. Sometimes I remember we bogged people's computers down when we would talk about that in the fall, so I made a similar water, but there's less than what we did in the fall. Is your computer running okay?
Yeah, it's not as hot as it was then.
Okay, not as hot as in the 148 class when we did the different. Because we did water and sky, didn't we?
I think I wound up disabling. I think they were in the same one, but I wound up disabling it, and it still was like.
Yeah, because once it heats up, it stays hot. Yeah. It takes a long time to cool off, but that can make this week's game look a little bit better. And shaders are that's the highlight of Unreal. That's what everybody's wanting done. The writing some code to move graphics around. That's the same in any game. So a lot of y'all are probably thinking about shaders. Those are getting really nice. Created some nice shaders. Hopefully that's coming to the camera okay. Maybe I can make it a little bit.
So on the fake bottom for the swimming thing, would you put the alpha to 0 and that would be just all you have to do? True.
That would work. Sometimes I would use a blue. But yeah, just set alpha equal to 0.0 and you have a transparent shader with alpha equals 0 and you just have a transparent material. The object is there, but you can't see it.
You want it to be something you can see while you're debugging, but eventually you want it invisible so players can't see it.
Yes, so normally what I would do is just leave it, maybe even no material, and then when it's finished debugging, just turn it off with the little eyeball thing so the players never see it.
Oh, so if you turn the eyeball off on here, then when you do the final export thing, it's not visible. Like,
Oh, if you extend it from Blender, Right, we have an eyeball right here.
But no, I meant like, if you turn it off there, like, you click the eyeball off on here, whatever, then when you export and finalize the project, that is not visible then. Okay,
That's correct.
but it's still there physically.
It's still there, yes. Yeah, that turns off the graphic, just the visibility of it.
I didn't know if that was just I kind of knew that it did that. I didn't know that it kept that when you like finished the game. You know what I mean? Like,
Yes, for the final export, any setting you make in the editor gets exported. So actually, the export is exactly what you have when we do the run to test it. The only difference is the run to test it is exported to your local computer. So it's exactly the same. So like if you're on your Windows machine and doing a Windows desktop export, it goes really, really quick because you get the exact same thing you had every time you ran it while debugging. Any questions about that? Definitely something to play around with, right? I've got some odds and ends, a list of odds and ends for Wednesday, which will be our last day of class. But this time of the semester, y'all are probably wanting time to work on stuff, right? Like, oh, there's so much stuff to do. Got a huge to-do list and massive amounts of stuff to do in every class. I know how that goes. So I wanted to make sure there's lots of time. So right now, your schedule should be blocked off for what? Another 2 hours and 20 minutes?
actually, oddly enough, this time around, coaching costs. There's so yesterday.
Oh, interesting.
Yeah, that's the first time I've had that.
Well, there's time to work on stuff.
Yeah.
If you need any help, I will be around. I might not be sitting in my office, so a text message will be the quickest way to get hold of me, or heavy learn messages, make noise on my phone. So I'll be probably walking around campus and stuff. Running errands, but I can hop on a Zoom call very, very short notice if you have any questions. Might be a good time to work on group projects, meet with your group. Everybody in your group should have, if you have a group left. Everybody in your group should have this time blocked off on their schedule, so it might be a good time for that. Otherwise, y'all have a great day, and I'll see you on Wednesday, and we'll just look at some random odds and ends and to kind of finish up the semester. We might take a glance at some other engines, but that's really time consuming because we have to install it. I'll see y'all Wednesday.